In this lesson, we'll talk about how do I create equations to find consecutive values. So let's start by defining consecutive terms. Consecutive numbers, if we're talking about integers, are a sequence pattern of 2, 3, 4, 5, 6. They're all in sequence with each other. They're said to be consecutive. So I can make that argument with negative numbers as well, -9, -8, -7, -6, and so on. So I'm looking for those that are connected to each other. We'll also talk about consecutive even and consecutive odd numbers. But let's start out with consecutive integers. So what we need to understand is what is the pattern, what is the sequence between these values? And we talked a little bit about sequencing in our warm-ups. So if I'm thinking about the pattern, let's say 7, 8, and 9, I need to think about how do I get from one value to the next value. Now recall, I have mentioned we can only solve for one unknown variable at a time. So I need to establish one of my terms as that unknown value. So let's say I'm looking for 3 consecutive integers. That first value is going to be my x value. So what is the pattern to get from that first number to the second number? So you're thinking about, well, I added 1. So the second number is going to have a value of x plus 1 because I have to write it in terms of the first value. So then what does it take for me to get from the first value to the third value? Again, that first value is x, but I actually added 2. So the second number would be x plus 2. If I were looking for 3 in a row, what would it take for me to get from that first number to that second one? We would write it in terms of x plus 3. So to find consecutive numbers, I'm looking at taking the first value, setting it equal to my variable, and then each consecutive number is found by adding to it. So let's take a look at the problem to find 3 consecutive numbers whose sum is 126. So we know that the first integer in this pattern is going to be x. The second integer in that pattern, and it's always going to be this pattern, is going to be x plus 1. The third integer in the pattern, again, in relationship to the first, is going to be x plus 2. So we create our equation by adding those because it says the sum of those 3 values. So here's my first term. I'm going to add to it my second number. Here's the second number. I'm going to add to that my third number. And set it equal to the 126. Now it looks like an equation we've solved before. I'm going to collect together my x's, which gives me 3x, add together the other terms, which is plus 3, and I'm going to solve for x. So 3x is equal to 123. I'm going to divide by 3, and x is equal to 41. So this is my x value. Going back up, x is equal to 41. So if I have x is equal to 41, 41 plus 1 is equal to 42. 41 plus 2 is going to give me 43. So my 3 consecutive numbers that give me the sum of 126 is 41, 42, and 43. And I can check that by adding those 3 numbers together. Let's talk about even integers. A little bit different. So even integers consecutive are 2, 4, 6, 8. Those are consecutive. I could even think about -8, -6, and -4. And we're going to construct it in the same way that we did before, thinking about what is that pattern. So if I say that the first term is x, what is the pattern to get to the next one? Well, it's every other one, so I'm going to add 2 to that. To get from 2 to 6, we're going to add 4. To get from 2 to 8, we're going to add 6. If I were looking for 4. Down here in the bottom, it still works out the same. If I let the -8 equal x, to get from -8 to 2, I actually added 2. To get from the -8 to 4, I've added 4 to my original term, that idea that that first term is always considered to be x. So we're going to think about my pattern as x plus 2, and x plus 4. And if I have more integers, we would add more to that. So let's take a look at finding 3 consecutive integers whose sum is 162. So we're going to construct our equation, x, that's the first one, because we're looking for 3 evens, x plus 2 and x plus 4, setting that equal to 162 because it asks for the sum. Doing like we did before, I have 3 x's plus 6 is equal to 162. 3x is equal to 156. And then x is equal to 52. So x is 52. 52 plus 2 is 54. 52 plus 4 is 56. So my 3 consecutive even numbers are 52, 54, and 56. Let's take a look at odd integers. Interestingly enough, this one's going to behave in a very similar way. So odd integers, we have 3, 5, and 7. Thinking about it again, if this is x, now this is tricky. I'm going to go from 3 to 5. It's every other one. So to get from 3 to 5, guess what? I added 2. To get from 3 to 7, I added 4. That looks a lot like the same pattern that I had with the evens. But if you think about it, every other number is 2 away from each other, whether it's odd or even. Even if I use this with negative numbers, -9, -7, -5, letting this be my x, we are adding 2, and we're adding 4 to the pattern of the original x. So that's where students tend to get a little thrown off. They don't realize that the pattern for consecutive evens is the same as consecutive odds, but that's because every other number is even or odd. So my pattern will be the same, x, x plus 2, and x plus 4. And I would continue to add x plus 6, x plus 8 if I were adding more to my sequence. So let's take a look at odd integers, the sum of. This is the number that's going to determine whether or not I'm looking for odds or evens. Whatever number's out here is going to make that difference. So we set it up. Here's my first number. Bring down my second number. X plus 2 represents my second number. X plus 4 represents my third number. And I set it equal to 51. Collect together the x's, 3x. We have plus 6. Wow, this looks a lot like our other example. Okay, we're going to solve for x. 3x is equal to 45. So x is going to equal 15. So x is equal to 15. 15 plus 2 is 17. 15 plus 4 is 19. So my 3 consecutive odd numbers are 15, 17, and 19. Rewatch this video several times as needed in order to complete the problems 1 through 5 on the rest of this worksheet.